Hello guys, this particular video was filmed around 2020 and was waiting for editing in my video files until today, because I never found time due to workload. A few days ago when I was searching for old footage on my video folders, I accidentally came across with this video file, and I said let's do it now because I believe that it will be interesting. The purpose of the video was to see if we can run DC motor with a 3-phase BLDC controller. So I got a new controller which was able to work without Hall sensors, because as we all know DC motors do not have sensors. The controller was at 3648 volts with maximum output of 18 amps at 350 watts rated, and around 800 watts maximum output. So to work a DC motor with BLDC controller, my first idea was to connect a 3-phase rectifier to the motor wires of the controller, which will convert from modified AC current to DC current. Since I didn't have a big bridge at the time, I connected a small one that I had just for testing, which was at 10 amps only. As you understand, normally we had to find bridge that was more than 60 amps, because as we said in previous videos, at the output of phases we have twice or even 3 times more current that can output the battery line. Now, let's do the basic wiring to see if our experiment will succeed. First, I will start with the power motor wires. On the pins of the rectifier, we connect the 3-phase wires to the pin that has the indication of the alternating voltage. From the rectifier we have 2 pins left, which are the output for our DC motor. Here we have the plug with the throttle wires. red, which is 5 volts power, green signal, and black the negative. Now I will connect my variable power supply. I set it at 45 volts, which is at the controller voltage range. As you can see, as soon as I connect the thin red wire, which is the ignition, I have a very small consumption on the power meter display. At that moment we know that our controller has been activated. The DC motor that we will use today is from a Razor electric scooter E300 at 250 watt of rated power. Now let's see the result of our experiment. Here we can say that our motor is working normally. As you can see, we can also control the shaft rotation speed, which is very important. After the experiment on the scooter motor, I got an idea to try it on a very old DC electric bike which I had in my lab. The truth is that I was surprised, while the motor was running so smoothly, like from the factory one. The only change I would make to this particular setup is to put a much bigger rectifier, as I said from the beginning. So that's it for today guys, and see you in the next video.